Hi boys and girls, today we will be working on lesson 25 problem set, and this lesson is decomposing and composing fractions greater than a whole and expressing them in various different forms. So we will read directions number 1 to convert or change each mixed number to a fraction that is greater than a whole, and then we will draw it on a number line to model what we've done. So starting with part A, we always want to define our unit fraction. That is also what our number line, each of the wholes on our number line will be divided into. That is also equal parts. So these will have 4 equal parts, and the number line is showing you that the whole number 3 1/4, that's our problem, 3 1/4, needs to be modeled with a number line. So we're going to go ahead and start our number line to reflect 3 wholes. And again, it starts at 0. And because the number is greater than 3 and it's got 1 extra fourth to it, we need to go an extra whole all the way from 0 to 4. So here is defining each whole on the number line, and then they have divided each whole into 4 equal parts. So to represent the 3 wholes, they have done 1 whole, 2 whole, 3 wholes, and that is what this large jump is for. 3 wholes represented here is the same as counting by 4s. Count with me, 4, 8, 12. So this 3 wholes is really 12 fourths. This would be 4 fourths, this would be 8 fourths, and this would become 12 fourths. But this number has 1 extra fourth with it, so they've got to do 1 little extra 1/4 jump here. So that's where it gives us 12 fourths and then an extra 1/4 to represent the 3 wholes here and the 1/4 here. They've broken it down. 3 1/4 is the same as 3 wholes plus an extra fourth. That is also the same as 3 wholes here become 12 fourths, and then we don't want to forget that extra 1/4. 12 fourths plus an extra 1/4 gives us 13 fourths. So these two numbers are converted at this point. Part B, let's do that one together. Let's define our unit fraction, which is 5, otherwise known as fifths. So we will have, on this problem, 5 equal parts in our number line. So our number line becomes, here is our number 2 4/5. Our number line now becomes, you know you have to have 2 wholes to begin with to represent the 2 wholes here, but we have a little bit more after the 2 wholes, so we're going to need to add a 3rd whole to represent 2 wholes plus a little extra 4/5. Each of these parts is divided into 5 equal parts, so that means 4 cuts. 1, 2, 3, 4. That's divided into fifths. 1, 2, 3, 4. That's divided into fifths. 1, 2, 3, 4. That's then divided into fifths. So to represent the two wholes, we want to model it this way. This is 2 wholes, as you can see on the number line, but it is really 5, 10, 10/5. We have an extra 4/5 after this, 1, 2, 3, 4. So our next jump goes from here to here, and this is represented by 4/5. So our 2 wholes are represented here. Our 4/5 are represented here, not quite another whole, 4/5. 1 more fifth would have gotten us there. And now we need to represent this like they showed us here, modeling our work this way. So we want to start with 2 4/5, which is the exact same as 2 wholes plus 4/5, which is also broken down. When we decompose this, we've got our 10/5, which represents that 2 wholes, and then we have not forgetting that 4/5, and when we add that together, it becomes 14/5. Now, we've talked about shortcuts, and I think you all will remember this, but if you remember in class, Dr. Smith and I talked to you about the shortcut for converting this number to this number, and it is 5 times the 2 wholes plus the extra 4. So 5 times 2 is 10, plus 4 more is, right, 14, and then we keep the unit fraction, which is our 5. We will do this shortcut again later in the problem set, but again, 2 and 4/5, doing it the shortcut way, becomes 5 times 2 plus 4 more gives us 14. 10 plus 4 more is 14. Keep the unit fraction the same. But as you can see, what you are required to do based on the directions is take this, convert it this way with the number line, then do your number work here, and if you'd like to do a shortcut, you can. Go ahead and pause the video so that you can complete C, D, and E. All right, boys and girls, moving on to number 2. Again, they want us to convert each mixed number to a fraction that's greater than 1. Show your work as they have done in the example here. Let's look at our first example, part A. Define your unit fraction, which is fourths. That will end up being your equal parts also, but we don't have a number line this time. They're not requiring that for this one. What they're doing is they're simply breaking down 3 3/4 into 3 3/4 is the same as 3 plus 3/4. This 3 holes here becomes 3 times 4/4. 4/4 is just simply 1 whole. So this is the same as saying 3 times 1, which is really the same as the 3 holes right here. And then you don't want to forget that extra 3/4 here, and it becomes your 3 holes here become 12/4. Why? Because you've got 4/4 is 1 hole, 8/4 is 2 holes, 12/4 is 3 holes. And then again, you don't want to forget that 3/4. Don't leave him hanging there. And you've got your 12/4 plus your 3/4. 12 plus 3 is 15. Keep your unit fraction as 4. And if you're interested in the shortcut, also you have to do this work. The shortcut is just a way to check yourself. If you want to do the shortcut, you can do 3 3/4 and do the trick, which is 4 times 3 gives you 12. 12 plus 3 more gives you 15, and keep your unit fraction. And you end up with these two converting. All right, let's do part B together. And again, your unit fraction is thirds for this problem, so you're going to be working in thirds in your brain. The mixed number is 4 1/3, so you want to keep those 4 holes in your mind. You've got 4 1/3 to begin is the same as, again, 4 holes, add the 1/3. You've just decomposed this into an addition. You want to take that number and break it down a little bit more into 4 times 3/3. This is essentially the same as saying 4 holes. 4 holes is the same as saying 4 times 3/3, which the 3/3 is 1 whole. You don't want to forget, I know it seems a little redundant, you don't want to forget the 1/3. And again, this all becomes 4 holes now has to be converted into, how do we get there? 4/4 is 1 whole. our unit fraction is thirds. 3/3, 6/3, 9/3, 12/3. So 12/3 is the same as your 4 wholes. And then you don't want to forget this extra 1/3. 12/3 plus 1/3 equals 13/3. And if you'd like to do the shortcut again, shortcut becomes 3 times the 4 is 12, plus 1 is 13, and you keep the unit fraction thirds, and that matches to that. So you've got your 4 1/3. Oops, I made a mistake. If we were in class, somebody would have caught me on that, but I just caught myself. That should have been thirds, not 13. That becomes 13/3. 4 1/3 converted becomes 13/3. Boys and girls, take a time to pause my video and you can complete C and D on your own. Last but not least, number 3, we're going to pull back even more and we're going to convert each of these mixed numbers again to a fraction greater than 1, and we have not much space to work with, so let's define our unit fraction there as fourths. And what we want to do is convert two wholes, 2 3/4 is what we're converting, but let's just simply start with 2 wholes. 1 whole would be 4/4. 2 wholes would be 8/4. So 2 wholes converted is 8/4, and then we don't want to forget that 3/4, so we want to add our 3/4. 8/4 plus 3/4 gives us 11/4. If you want to do the shortcut, 4 times 2 is 8. 8 plus 3 is 11. Keep your denominator or your unit fraction and it works, and it's 11/4. Part B, we want to convert 2 2/5. Define our unit fraction, which is fifths. We want to convert 2 wholes. So 2 wholes is the same as 1 whole is 5/5, 2 wholes is 10/5. And again, that is just times 1 times 2. That's how I got 10/5. 2 wholes is 10/5. Don't forget to bring over your extra 2/5. 10/5 plus 2/5 is 12/5. To check ourselves and see if we are correct, we take 5 times 2, which gives us 10. 10 plus 2 more is 12. That becomes 12/5, and that is correct. So we have converted this fraction to this fraction and this one to this one. All right, boys and girls, go ahead and finish out part 3, C through I. Good luck.